Ever wonder why self-control seems to just evaporate when we're online? Well, this analysis suggests it's not about a personal failure of willpower. Not at all. It's actually a predictable outcome baked into the very design of the system. We're going to dive into the mechanics of how that architecture works. All right, first things first. Before we can understand how the system breaks, we have to know what it looks like when it's stable. So let's imagine a world with natural limits, a constrained environment. This is our starting point, our baseline.
So in this baseline world, things are in balance. Your attention is stable because you're not being bombarded with a million things at once. The amount of stimulus coming at you is manageable. It's below your saturation point. And this is crucial. There's friction. It takes a little time and effort to do things. That means the mental load is spread out and the choices you face are limited and clear. Basically, the environment itself is doing most of the heavy lifting when it comes to regulation.
Okay, so if that's the stable state, what blows it all up? It turns out it's not 1,000 different things. It comes down to one single, incredibly powerful mechanism. Let's take a look.
And here it is. The culprit is constraint removal. This is the absolute heart of the matter. Modern digital environments are engineered to be masters of three things. Number one, eliminating friction to make every action effortless. Number two, compressing feedback time so you get instant results for everything. And number three, maximizing the availability of stimuli, creating a literally endless field of options.
So what happens when you systematically remove all those external constraints? What's left to regulate your behavior? Well, there's only one thing left: you, your own executive function. Your self-control suddenly becomes the one and only line of defense, forced to do a job that the entire structure of the physical world used to handle.
This massive shift in responsibility doesn't just happen quietly. It kicks off a powerful chain reaction. Let's trace the cause and effect here, because this is where you can really see how the effects start to pile up and snowball.
And this is how that nasty feedback loop gets going. It starts with that explosion of options, which just shatters our attention into tiny pieces. With our attention fragmented, our brain's working memory goes into overdrive, constantly switching from one thing to the next. All that constant gear shifting just drains our mental gas tank, our finite executive control. And when that tank is running low, what happens? Our ability to say no to an impulse just withers away. We become way more reactive, just grabbing at whatever is newest or shiniest, which, of course, just exposes us to even more options. And boom, we're right back at step one. It's a cycle that just keeps feeding itself.
The result of this loop running over and over again is a total migration of responsibility. The job of regulating behavior, which used to be shared with the outside world, now falls entirely on our internal cognitive architecture. It's a burden our brains were simply never designed to carry all alone.
Okay, that's the micro level, the chain reaction itself. But what does this look like from, say, 30,000 feet? Let's zoom out and look at the new kind of behavior that emerges from the system as a whole.
This is a perfect way to see the before and after. We shift from the environment acting as a stable, predictable control layer to a volatile buffer that runs purely on our willpower. Decision friction, which used to slow us down and make us think, collapses to almost zero. The field of choices explodes from something manageable to something practically infinite. And you can see the fallout, right? Building stable habits becomes incredibly difficult, and our ability to plan for the long term gets completely bulldozed by the constant urgent pull of short-term rewards.
And these aren't just random side effects. These are the predictable, emergent properties of this new system. The time between seeing something and reacting to it just collapses. Long-term goals, like we said, fade into the background as these short, instant reward loops take over. And maybe most importantly, control failure stops being an accident. It becomes a predictable, regular output of how the system is now designed.
So where does all this lead? Well, the system eventually settles into a new kind of normal, a new stable equilibrium. But as we're about to see, just because something is stable doesn't mean it's good. And this is it. This is the end state. It's a stable equilibrium of chronic control depletion. What does that mean? It means the system finds its balance in a state where our self-control is just permanently overtaxed, constantly running on empty. The high-stimulus, low-friction design of the environment makes sure it stays that way.
So what's it like to operate inside this end state? Well, our behavior just naturally starts to drift toward reactive, impulsive patterns. Our self-control is always on. It never gets a break. But, and here's the key, it is structurally insufficient. That image of using a bucket to bail out a sinking ship is perfect. You're constantly working, but you are fundamentally outmatched by the scale of the problem.
And that really brings us to the final, unavoidable takeaway.
The logic of this system is ironclad. It locks itself into a loop where the very thing that defines these environments, the complete absence of constraints, is the very thing that guarantees persistent failure of self-regulation. So, to put it another way, it's not a bug in the user, it's a feature of the architecture.